integration by substitution, or U sub, with definite integrals, where a definite integral is an integral with limits. There are really two ways to handle a U sub with definite integrals, and we'll see this by an example, or two or three, or whatever. What if we want to integrate x over root x squared plus 1 from 0 to the square root of 8? I recognize it as U sub. If I let U equal x squared plus 1, then du is 2x dx. We have almost enough of our 2x. We need a 2 up here to fix it, to give me the full du, and a 1/2 outside to fix the 2, so we don't change the expression. But we're not done yet, because here my limits, you have to remember, are from x equals 0 to x equals root 8. So we really need to change everything with x's into something with u's. So the first way to handle this is to put placeholder limits, a to b like that, and then put du over u to the 1/2. And then we can integrate. We get 1/2. So we're integrating u to the negative 1/2, which says we'll add 1 to the power, we'll divide by the new power or flip and multiply that from a to b. And then we can back substitute, giving us u to the 1/2, or the square root of x squared plus 1, from x equals 0 to x equals the square root of 8. So method 1 is to put placeholder limits. I usually put a and b. Integrate, back substitute x's, and then replace our x limits that we had originally. And if we plug in x equals the square root of 8, we get the square root of 9 minus the square root of 1, which equals 2. That is certainly a way to handle this. I usually do it a different way, though. So the way I usually handle a U sub with definite integrals, I go through the same process that I end up here with du over u to the 1/2 by doing my same U sub. But instead of putting placeholder limits, I'm going to put limits in terms of u. Notice that when x equals 0, my lower limit, I get u equals 0 squared plus 1, or 1. So instead of putting a placeholder limit of a, I'm going to put 1. And then my original upper limit, x equals root 8, gives us u equals root 8 squared plus 1 equals 9. So I put 9 as my upper limit. And then when we integrate, once again, I won't go through all the steps, we end up with u to the 1/2 simplified. I don't back substitute x's, I just leave everything in terms of u, where I get the square root of 9 minus the square root of 1, and we get the exact same answer. Let's do at least 2 more examples. How about if we do the integral from 0 to 1/2 of the sine of pi x plus pi over 4 dx. This is a U sub. What are you going to let U equal? No pun intended. If you said, what's inside parentheses, I would agree with you. Let U equal pi x plus pi over 4. Then du is pi dx. We almost have all of du. We're off by a constant multiple. So I'll do times pi out here at the end, and then 1 over pi in front to fix it. And then we can rewrite this as 1 over pi times the integral of sine of u du. And I'm going to turn my x limits, x equals 0, into u limits, pi over 4, right? When x equals 0, we get u equals pi times 0 plus pi over 4. And then when x equals 1/2, my original upper limit, we get u equals pi times 1/2 plus pi over 4, or 3 pi over 4. So I like to change everything to u's and just leave them as u's. The integral of sine is negative cosine, so I have negative 1 over pi times the cosine of u, from pi over 4 to 3 pi over 4. I like to leave my constants alone until the end. I'll just pull it outside. And now we do the fundamental theorem of calculus part 1, where we plug in the top limit. So the cosine of 3 pi over 4 is negative root 2 over 2, minus the cosine of pi over 4, root 2 over 2, giving us negative 1 over pi, times negative 2 root 2 over 2, or negative root 2, for a final answer of root 2 over pi. Another example, probably our final one. Let's do the integral from 0 to 1 of e to the negative 2x dx. This is a u sub. We did this one in the last video. U equals negative 2x. Du is negative 2 dx. We need to fix this, multiplying by negative 2 and negative 1/2 on the outside. And now we can integrate. So negative 1/2 e to the u du. Oh, we still need our limits. So when x equals 0, u is 0. Okay, that's good. When x equals 1, u equals negative 2. So my limits change. Well, the bottom limit doesn't change, but they become 0 to negative 2. Now we find the antiderivative. So these are now in u's. I'll put u's just to remind ourselves those are u's. The integral of e to the u is e to the u from 0 to negative 2. Leaving my constant alone to the end. Plugging in the top limit, we get e to the negative 2 minus e to the 0, which equals 1/2 minus 1 over e squared.